Student, last class we have seen what is entropy, what is the change of entropy in the reversible process, and what is the change of entropy in the irreversible process. So what is entropy? A thermal property which remain constant during the adiabatic process is called entropy. It's called entropy. This is denoted by S. So the equation for entropy the equation for entropy can be determined in the following manner. Let us take three isothermal processes which are at the temperatures T1, T2 and T3, and let us take two adiabatic processes A and B which are cutting the three isothermal processes. Because of this, we can get two Carnot cycles A, B, C, D, A, D, C, F, E, D. From Carnot cycle A, B, C, D, A, we can write the from the thermodynamic scale of temperature, we can write Q1 by Q2 equal to T1 by T2. From that, we can write Q1 by T1 equal to Q2 by T2. Again, from DCFET reversible Carnot cycle, we can write Q2 by T2 equal to Q3 by T3. From these two equations, we can write it as Q1 by T1 equal to Q2 by T2 equal to Q3 by T3 equal to Q2 by T2, that equal to S, which is called as entropy. So the equation for entropy is F equal to Q by T. But as I said earlier, we cannot measure entropy, only we can measure the change in entropy. So the change in entropy Ts equal to dQ by T. So this is what is about entropy. Now after that, we have seen what is the change in entropy in the reversible process. Again, in order to find out the change in entropy in reversible cycle or reversible process, we have taken another Carnot cycle A, B, C, D, A. From this Carnot cycle, you can, as you well know about the Carnot cycle, in the Carnot cycle, we have four operations: isothermal evaporation, adiabatic evaporation, isothermal compression, and adiabatic compression. From A to B isothermal evaporation, the increase in the entropy can be written as Q1 by T1. Similarly, from C to D isothermal compression, the decrease in the entropy can be written as Q2 by T2. As you well know about the entropy, from B to C is an adiabatic process and D to A is an adiabatic process. In these two processes, entropy is constant. So now the overall change in the entropy in the entire Carnot cycle, delta S can be written as S1 minus S2. So Q1 by T1 minus Q2 by T2. As you well know, from Kelvin scale of temperature, Q1 by T1 equal to Q2 by T2. So if you substitute this in this equation, delta S becomes 0. That means the change in entropy is 0 in the reversible process. So again, we have proved that the change in entropy is increases in the irreversible cycle as below manner. As you well know from Carnot theorem, the efficiency of a reversible engine is always greater than the efficiency of irreversible engine which are working in the same source and sink. So if you write the efficiency of irreversible engine, eta IR equal to Q1 minus Q2 by Q1. The irreversible engine means the normal heat engine. As you well know about the equation for efficiency of a normal heat engine, that is Q1 minus Q2 by Q1. So the efficiency for irreversible Carnot engine, eta R equal to T1 minus T2 by T1. So as per Carnot theorem, you well know from Carnot theorem, efficiency of irreversible engine is always less than efficiency of reversible engine. So from this, Q1 minus Q2 by Q1 is less than 1 minus T2 by T1. So if you cancel 1 and 1 on both sides, we can write as Q2 by Q1 is less than T2 by T1. If you take the T2 into T2 to left hand side and T1 to right hand side, we can rewrite the equation like this. Q2 by T2 greater than Q1 by T1. So, or we can rewrite this equation like this. Q2 by T2 minus Q1 by T1 is always greater than 0. That means this gives us the change in entropy, that is delta S greater than 0. That means the change in entropy increases in the irreversible process. As you well know, what are the examples of irreversible processes? All natural processes are irreversible processes. That means in all natural processes, the entropy, all the change in entropy always increases, always increases. So these are the topics we have covered in the previous class. Now we can see what is entropy and disorder and what is TS diagram. That means temperature entropy diagram. So you see what is entropy and disorder. So what is entropy? As you well know, the thermal property which is remain constant during the adiabatic process is called entropy. So from this topic, we can say that entropy is a measure of degree of molecular disorder. Entropy is a measure of the degree of molecular disorder. That means if a system transits from one position of to another position, that means if a system transits may get transition from orderly position to disorderly position, then the entropy of that system can increases. If a system may get transition from orderly position to disorderly position, uh, that system's entropy increases. For example, you see, if you heat a gas, then the molecules in the gas absorbs the heat energy and their kinetic energy increases, and may they random motion may increases. That means the system's disorder position may increases. So then the entropy of that system increases. So entropy is we can also say that entropy is a measure of degree of molecular disorderness. And this can be explained by the equation as per the by Boltzmann equation. What's that Boltzmann equation is? S equal to K log W, where K is the Boltzmann constant and L is the called thermodynamic probability. So Boltzmann explained this disorder, entropy on disorder, with a probability, with a theory of probability, as with the equation S equal to K log W, where W is the quantity W is called thermodynamic probability, and K is, as you well know, K is Boltzmann constant and S is the entropy. So the entropy is a measure of molecular disorder, degree of the molecular disorder. This is a very important topic. So again, after that, we can see temperature entropy diagram. This is a very important one. Temperature entropy diagram. So in the previous class, we have seen PV diagram, that is also called as indicator diagram. In PV diagram, we have taken pressure on the y-axis, volume on the x-axis. So that diagram is called as PV diagram or indicator diagram. So all the operations in the Carnot engine have shown in the PV diagram as a Carnot cycle. So here, what is temperature entropy diagram? If you take temperature on the y-axis, and entropy on the x-axis, then this diagram is called as TS diagram. TS diagram. Suppose, what is the advantage of this TS diagram? What is the importance of this TS diagram? If you show the Carnot cycle, which is in the PV diagram, in terms of TS diagram, this can be shown like this. You see the Carnot cycle in the PV diagram is in bit yeah, it will be shown with the curves like this. So the isothermal evaporation can be shown with a curve AB. The adiabatic evaporation can be shown with a curve BC. Similarly, isothermal compression can be shown with a curve CD. Similarly, the adiabatic compression can be shown with a curve TA. That means the whole Carnot cycle in between the curves in the PV diagram. If you draw the same Carnot cycle in the TS diagram, this whole Carnot cycle can be shown with a straight lines like this, and the diagram is like a rectangular diagram. కనుక మనము పివి సూచి పటములో వక్రరేఖల మధ్య ఉండేటువంటి ఈ కార్నాట్ సైకిల్ ని మనము టిఎస్ పటంలో కనుక మనం చూపించినట్లయితే మనము సరళరేఖల మధ్యలో ఒక రెక్టాంగులర్ దీర్ఘచతురస్రాకారపు సరళరేఖల మధ్యలో ఉండేటువంటి కార్నాట్ సైకిల్ ని మనం చూడవచ్చును. దిస్ ఈస్ ద అడ్వాంటేజ్ ఆఫ్ టిఎస్ డయాగ్రామ్. యాజ్ యు వెల్ నో the area under the curved Carnot cycle will give us the total work done. So it is very difficult to find out the total work done, to find out the area of the Carnot cycle. Why? Because this whole Carnot cycle in between the curves. Whereas you see in the TS diagram, the whole Carnot cycle can be shown as a rectangular one. So you can easily find out the total area of this whole diagram, and you can easily find out the total work done in the Carnot cycle. సో కనుక మనం పివి డయాగ్రామ్ లో వక్రరేఖల మధ్య ఉండేటువంటి కార్నాట్ సైకిల్ యొక్క ఏరియాని కనుక్కోవడం చాలా కష్టం. అదే టిఎస్ పటానికి వచ్చినట్లయితే ఈ టిఎస్ పటంలో ఈ కార్నాట్ సైకిల్ దీర్ఘచతురస్రాకారంగా ఉండేటువంటి ఆ పటం ద్వారా చూపించబడింది కాబట్టి మనం దీని యొక్క ఏరియాని చాలా ఈజీగా సూత్రం ద్వారా కనుక్కోవచ్చు. తద్వారా మొత్తము జరిగిన పనిని కూడా మనం తెలుసుకోవడానికి అవకాశం ఉంటుంది. కనుకనే మనము if you show the PV diagram of the Carnot cycle in terms of TS diagram, it can be you can find out easily the total work done by using this TS diagram. That is the beauty of this diagram, TS diagram. You see, so in the TS diagram, you can take the temperature on the y-axis and the entropy on the x-axis. You see, here we can see step by step, operation to operation, how TS diagram can be drawn for Carnot cycle. If you take AB operation, AB process, that means isothermal evaporation can be shown by a AB curve. That means from A to B, the whole temperature is constant at T1. So this curve can be shown like a straight line which is parallel to the y-axis from A to B, which is parallel to the y-axis. Why? Because from A to B, the whole temperature is at T1. So this can be drawn like a straight line in the TS diagram. Similarly, you see the temperature is at a temperature T1. Now, if you see the adiabatic process from B to C, here the temperature changes from T1 to T2. From B to C, the temperature changes from T1 to T2. At the same time, the entropy is constant from B to C. That is why here this same curve can be shown like a straight line from B to C, which is parallel to the y-axis. Here, the temperature changes from T1 to T2, and this entire process entropy is constant. That is why this will become a straight line which is parallel to the y-axis. Similarly, if you see another process that is from C to D in the PV diagram, this indicates isothermal compression. Here in this isothermal compression, the whole process is at the temperature T2. That means temperature is constant at T2. So that is why this curved line will become a straight line in the TS diagram from C to D. This whole process is at temperature T2. So this will become a straight line, and again it is parallel to the x-axis. So now the final process, what is that? Adiabatic process, adiabatic compression. In this adiabatic compression from D to A, the temperature changes from T2 to T1, and in this whole process entropy is constant. That is why this curved line from D to A in the PV diagram can be shown like a straight line from D to A, which is again parallel to the y-axis. Now you see the whole process, the four processes in the PV diagram can be shown like a four straight lines, which gives us a rectangular diagram. From this diagram, you can easily find out the area of the rectangle. From that, you can easily find out what is the total work done in this Carnot cycle, Carnot engine. This is the beauty of this temperature entropy diagram. So the four processes which are in the curved lines will be shown as a rectangular diagram in the TS diagram. Rectangular diagram in the TS graph, temperature entropy graph. So if now we can, if you see step by step, you can write. You see, in this PV, in this temperature, in the Carnot cycle, here from A to B, the amount of heat energy absorbed is Q1. So this amount, the entropy increases from A to B, So here the entropy can be written as S equal to, as you know, what is the formula for entropy? S is equal to Q by T. Therefore, Q1 by T1. Similarly, from C to D, the entropy decreases. So here the entropy can be written as Q2 by T2. Q2 by T2. So that is why we can write here, if the Q1 be the amount of heat energy absorbed from T1 at T1 Kelvin and Q2 be the heat resected at T2, then from the equation dq equal to TdS. No, I already said that we can measure the change in entropy, not the entropy. So what is the change in entropy? ds equal to dq by t. So from that equation we can write like this. What is ds equal to dq by t? So from this equation dq equal to tds. So what is the, in isothermal process, what is the dq here? The amount of heat energy absorbed from the source. Therefore q1 equal to, here instead of t you can write t1. And what is the change in entropy? S2 minus S1 from A to B. So q1 equal to t1 of S2 minus S1. So what is t1 here? So T1 is the T1 can be written as AF from x-axis to A. So what is the value of T1 here? AF. So instead of F, T1, instead of T1 we can write AF. Now S2 minus S1. So you see, yes. Here, this is S1. At A, the entropy is S1, and at B, let the entropy is S2. Now, the change in entropy, this is in the increasing order. The change in entropy from S2 to S1 or S1 to S2 can be written as S1 minus S2. That can be written as A into B. So that means AB gives us the change in entropy. AB gives us the change in entropy. So we can write S2 minus S1 can be written as AB. Therefore, AF into AB. That gives the area of ABEF. You see. So this is AF and this is AB. So this gives AF into AB, that is length and breadth. So that gives AF into AB gives us the whole area of this rectangular. That what is that? ABEF. ABEF. So if you take the isothermal expansion from the equation of change in entropy, we can show that Q1 equal to A B area of A B E F. Similarly, if you take isothermal compression, the amount of heat energy rejected to the sink Q2 equal to, we can show that the area of DCEF. DCEF. So, from isothermal expansion, Q1 equal to ABEF. From the isothermal compression, the Q2 equal to the area of DCEF. DCEF. Now, the amount of energy converted into work can be written as Q1 minus Q2. As you well know, when we are showing when you are learning about heat engine, so the amount of heat energy converted into work can be written as Q1 minus Q2. So what is Q1? The area of ABEF. What is Q2? The area of DCEF. So if you subtract, you see from figure, if you subtract ABEF, if you subtract DCEF from ABEF, we can get the area of ABCD. The area of ABCD. So here ABCD will become the area of ABCD. So the amount of heat energy converted into work can be equal to the area of ABCD. If you find out the value of area of ABCD, then you can easily convey the how much amount of heat energy converted into work. This is how one can find out from TS diagram how much amount of heat energy converted into work. Now let us see. We can show that the efficiency of Carnot engine equal to 1 minus T2 by T1. So this is also can be proved in the following manner. How we can prove that? You see, you know well about the efficiency of heat engine is Q1 minus Q2 by Q1. So what is Q1? Q1 minus Q2? The area of ABCD. We have written that the area of ABCD. What is Q1? The area of EBEF. The area of EBEF. So the area of ABCD can be written as you well know, what is the formula for area of a rectangle? Length into breadth. So from area of ABCD, we can write AB into AD. Similarly, the area of ABEF can be written as AB into AF. AB can be cancelled out in the denominator in the numerator. Then you can get AD by AF. So what is AD and what is AF? You see, this is AD. So from x-axis to A, the value of temperature from x-axis to A is T1. The value of temperature from x-axis to D is T1. If you subtract T1 minus T2, you can get AD. So AD can be written as T1 minus T2. T1 minus T2. Therefore, you see, AD can be written as T1 minus T2. As you know, AF is T1. So if you substitute T1 instead of AF, then T1 minus T2 by T1. Therefore, eta equal to T1 minus T2 by T1. That can be written as 1 minus T2 by T1. As you well know that this is the formula for efficiency of a Carnot engine. We have proved that from TS diagram, we have proved that eta equal to 1 minus T2 by T1. So like that, TS diagram is very much having more important than PV diagram. So if you show the whole Carnot cycle in the TS diagram, you can get the whole Carnot cycle in between the straight lines as a rectangular diagram. From that, you can easily find out the area of the rectangle. From that, you can easily convey how much of heat energy converted into work. And also we can prove that the efficiency of a Carnot engine as T1 minus T2 by using this TS diagram. By using this diagram. So again, there are so many uses of this TS diagram. So by using this, they are used in the metallurgy. Mainly, they are used in the metallurgy to predicting the defects in the engines. To predict the defects in the huge engines, to predict the what are the defects at which location the defect is can be predicted by this using this TS diagram to check the efficiency of the heat engine to obtain work value of the fuel used. So there are so many uses of this TS diagram. This is a very important one. So along with the Carnot engine, this TS diagram topic is also very important for examination point of view also. So in examination point of view, they can ask that what is TS diagram and how one can prove that from TS diagram the efficiency of Carnot engine is 1 minus 62 by T1. So you should read these two questions very thoroughly for an examination point of view also. So with this, the entire chapter of thermodynamic is over. So in the thermodynamic chapter, right from the beginning, we have seen so many definitions to understand the topic. So after that, we have seen what is isothermal process and what is adiabatic process. After that, we have seen what is zeroth law of thermodynamics and what is first law of thermodynamics. What is that? After that, we have learned about second law of thermodynamics. So after that, mainly we have seen heat engine. What is heat engine and what is Carnot engine? So what is a heat engine? The heat efficiency of heat engine very much less. So in order to get more efficiency, Carnot is the physicist who thought of a reversible engine that is nothing but Carnot engine. So in Carnot engine, it runs in the reversible manner. There are 4 operations will be run in the Carnot engine. Those 4 are isothermal evaporation, adiabatic evaporation, isothermal compression, and adiabatic compression. So if you show all these operations in the PV diagram, you can get a Carnot cycle. So these Carnot cycle is in between the curved lines. So we have explained each and every operation in the Carnot engine. So the total work done in the Carnot engine, from that we have proved that the efficiency of Carnot engine eta equal to 1 minus T2 by T1. 1 minus T2 by T1. So the efficiency of a Carnot engine only depends upon the temperatures of the source and sink only. After that, we have learned about entropy. What is the change in entropy in the reversible process? What is the change in entropy in the irreversible process? And what is and after that we have seen entropy and disorder. After that, we have seen today TS diagram. If you take temperature on the y-axis and entropy on the x-axis, then that diagram is called TS diagram. This diagram has very important when compared, more important when compared to the PV diagram. So by this TS diagram, we can